Hey, what's going on, guys? KIM-1 here. So for those of you who would ever want to write a KIM-1 emulator, here is a quite important note that I missed, and this caused a bug in my emulator, in my JavaScript emulator, the KIM-1. So the problem relies within so-called data direction registers. So there are two data direction registers on KIM-1, so-called PADD and PBDD, and DD stands for data direction. And I'm not really 100% sure about the PBDD, which ROM sets the value there at hexadecimal 3F and doesn't really seem to be changing, well, at least I didn't yet encounter situations where it could be changed. But in regards to this PADD, which represents the address 1741 hexadecimal, this address is absolutely essential. So if you have a look at the schematic of this circuit, you can see that the pins used by the keypad and those used by the 6-7 segment LEDs are actually shared. And the idea is that exactly these exact pins, exactly the same pins, might be used either to write the data to this 6-7 segment LEDs, or alternatively to read the data from the keypad, back from the keypad. And the problem, so there was an issue in the Hello World example I've been providing in the previous video. So my emulator was writing this data to the display, regardless of the data direction register state, and it kind of worked. And if you're not a purist, if you're not looking for the backward compatibility with the original KIM-1, you can just ignore this completely. But I decided to sort of emulate what happens if you will try to write to the display during the data direction register is not being set up properly. So thankfully to my friend Dominic Bambeka, who has been testing this on the Corsham KIM clone, we revealed that in that case, instead of flatters, it would be just, it would actually light up the LED, but not the value that we want, but instead it just would be the value of FF there, which means like all the segments being light up. That's pretty much how it works. And but yeah, I'm not going to be looking at this from this hardware perspective because I don't really understand that much. So instead I offered to have a look at this from the programmer's perspective, so from the software perspective. And here is the source code from a KIM-Venture game by Bob Leedom. And the very first initial routine, what it does, it prints something to screen, loads to print something to screen, and it really relies on the KIM monitor subroutine. But before actually writing anything to screen, what Bob does here, so he sets the value of 7F to the A register, and then sets this value to this PADD, which is the address 1741. And only in that case, when this constant is available at this register, it means that the data direction is set to write data to this LEDs. Because how this works on a KIM ROM, it just swaps back and forth. So once it displays the data, and next time it just reads the data from the keypad. And now, just to show you this a bit more visually, I would like to show you this the following way. So if we just say, so here is a function where CPU writes to memory. So we can say if address is equal to hexadecimal 1741. In this case, let's just log the value to the console so that we can see the value and to string and in the hexadecimal. And if we now go back to the emulator and update and go into developer tools, and now it runs, you see like it goes like 7F0, 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 and it's never ending mode, because again, like as I've been mentioning, so once it reads the data from the keypad, and next time it just writes it to the display. So that's how it kind of works. So just let me get rid of this sort of a thing. And finally, the very last example to demonstrate how this works in practice and how did I mimic this the original behavior. So what should happen if you mess up the data direction registers? So here is the updated hello world, well, just hello program. So if I just assemble this and upload and go into 0200 and run it, it prints hello. So far so good. But if we get rid of these two lines, so let's say I just comment these two lines out and then stop the program, and then assemble the program, and then upload the program again, and go into 0200, and go, and this is what happens. It just prints, has the value FF in every single segment. It does kind of put the values to the right segments, but the values are wrong basically. So this is what happens if you run this program on at least on the Corsium KIM clone. So I think this might be useful. So if you just forget to turn on the data direction registers, you will have this output. So more or less kind of like, you know, looks like it should look like basically. And again, like if we just stop this and restore writing the 7F to 1741, which is P80D, so data direction in the A register in the 6530 chip. In this case, if I assemble and upload and go into 0200 and run again, we got hello. So hopefully, well, I just asked Dominic to test this on the real KIM, so I hope this is gonna be working nicely there as well. But anyway, writing to like setting up the data direction registers properly is absolutely essential. Okay guys, this is it from my side. So new software, like not the new software, like new videos on the original authentic KIM-1 software running on this emulator, hopefully coming soon on this channel, so make sure to not to miss them. This is it from my side. Thanks for watching. Until the next time, and take care.